Our first example here out of the three is going to be inline classes. This is going to be the simple implementation of it, and that really is what you should expect to see for I'm going to call it much of the end of chapter exercises that have to do with this chapter 13. I'm going to call it A, and next session is going to be chapter 13. I'm going to call it B. So the things to notice here when we are working with inline classes are as follows. The actual order of operations here is going to matter. We have to have our class defined before we can use it. So whereas in functions, in structures, we had a little bit of flexibility for where it was that everything was placed. Here we do not. Absolutely positively, your classes should go up at the top. So first and foremost, here starting on line number 6, this is my class declaration. Again, you'll notice that the title for the class begins with a capital. This is the convention that you will follow. Now here, inside of your class, this is just the class prototype. At the very top, we have our private members. Now, these can be either or. They can be variables, or they can be function prototypes listed here. You'll notice that we have private, and then down here from 11 to 16 public. That really is what the preference would be as far as developer etiquette, I think is the proper way to say that. Can you have private, public, and then another batch of private members for your class? Yes. Don't do that. We're always assuming here with what we see with our, very relatively small developments here in our examples, that you're not going to be looking at hundreds of lines of code when we're looking at a production environment. And absolutely, that's not the case. The order of magnitude here is going to get very much larger. So do yourself a favor, do your career a favor, and do the next developer in the chain a favor, and list all of your private members of the class together and all of your public members of the class together. So here you'll notice we have our length and width as private variables, and we have here our public voids and public doubles for our functions. Immediately following that, we will have immediately following that, please remember you do need the semicolon here to delimit the class definition. And then when it comes to actually defining, so here's your program, your function stubs, right? The prototypes. And here would be our function definitions. You'll notice we have the return type and then the name of the class followed by 2 colons. This is the scope delimiter. What this is going to do is reference for C++ during the compile. This is going to reference these belong to the class. In this case, it's rectangle. If you forget this, your classes will not function. So you need to have the order of operations here. It's the return type. It's the name of your class, it's colon, and then the name of your function as usual. You will notice with these are going to be simple functions. We are simply passing along an argument, and the parameter is simply going to set width and length. Now, there's something I didn't talk about during the chapter because I knew I would talk about it here, and that's the idea of stale data. You'll notice that area is not something that we store here in our functions. It's not something that we actually have as a variable up above. So let's say on line number 11, we do not have a double area. Why is that? If the whole point is to find the square footage, so the area, why not have it as a variable? And that's because if we assign a value to it, we're not sure when we're going to get around to updating that in the live run of a program. So if we avoid that entirely and say, look, area is always a calculated field, and it's always going to be something that I calculate when I need it. That's going to help you avoid an error someplace. So if you think about, the use case here for finding out the rectangle if it's as applied to a house. So we're going to bid a job for painting. You guys can't see it. These walls over here are getting painted presently. And if we bid a job and we've made a mistake, we've put a contract out there that has the incorrect area for our job, once the customer signs that copy, it becomes your fault and your error. And that's certainly something that we want to avoid. So where possible, when you are dealing with calculated fields, don't assign them to a variable that can sit there and last. Simply call the function that returns the value with the current data, and that's going to prevent any stale data issues. Now, I won't go through absolutely everything here, but you can tell here on lines 50 through 52, we have our declarations for 3 objects of the class rectangle. So our 3 objects are going to be kitchen, bedroom, and den. And really from here, everything is going to function in the exact same way that you saw a scope or a structure function. So we are using the dot nomenclature like you see here on line 57. So kitchen, that's the name of our object, dot set length, and that is going to call to a rectangle object, and that's going to call to the rectangle object's set length member function. And down here, the only other thing I really wanted to point out to you was on line number 79. You can run this and see how it works. Here on line 79, you can see that total area is the resultant of 3 calls to our get area member function. So there is no stale data here. We've got data read in for our 3 objects, kitchen, bedroom, and den. And then once the data is in there, we can do the calculation with our last remaining necessary field. But remember, it's not a long-term stored variable. Total area comes from kitchen area, bedroom area, and den area, and they are calculated on the fly.